This is lesson 7.4, inverse trigonomic functions. So in this lesson, we're going to talk about how to find the inverse of a sine, cosine, and tangent functions. And so before we start into that, we kind of really need to define what that means. And the inverse or arc sine of x is simply working it backwards, right? So if sine of x or sine of theta equaled x, let me write that out a little better here because I don't like this explanation here. If I have sine of theta and that equals x, then the arc sine or sine -1 of x would equal the angle theta. Okay, that's a little clearer way of understanding it than the way they wrote it here, the inverse sine. They kept those x and y values in there, so it's a little bit confusing. So this is what that inverse would look like. And this is an inverse function, okay? And so because of that, we're going to have to put some restrictions on our domain in order to make that work. And so let's take a quick look at that. But before we do it, let's go ahead and just try to find a value that satisfies this. And so we're looking at what is the arc sine of radical 2 over 2? Well, we know that at 45 degrees, or pi over 4, that my triangle here is radical 2 over 2 and radical 2 over 2. So we know that this is good right here, is at pi over 4. But remember, sine is our y value, and so we also would have another value here where we would be that's our y value. So we're also at 45 degrees, or my reference edge, but this is actually 3 pi over 4, right? And so I can't have two y values for one value of x in order to pass that, right? So in other words, I would not pass a horizontal line test here. And so we have to address that. And so we do that by putting a limit on our problem, just like we kind of did, if you remember from Algebra 2, where you had the function y equals x squared, right? And the graph of that, of course, was a parabola. However, the inverse of that is y equals the square root of x. And we could not just do this, okay, because then we wouldn't pass the vertical line test, just like this doesn't pass the horizontal line. So what did I do? Well, I had to put a restriction here where x is greater than or equal to 0. All right, and so then that's the limit I put on this, so that my graph, instead of being that, would look like that. Okay, and so that's how we addressed it, is putting a limit on it. And so my sine graph here looks something like this curve, and you can see where between these 2 points here, negative pi over 2 and pi over 2, I have half a phase, right? And so in there, if I drew a horizontal line anywhere through these limits, I would pass the horizontal line test. But if I continued on to the full period, then I would not pass the horizontal line test. And so to address that, I have to put a limit on my domain, and that the limit for the sine function is from negative pi over 2 to pi over 2. And so any of these values for arc sine are going to occur in quadrant 1 or quadrant 4. I have similar restriction on my cosine function. Again, I have in order to prevent it from failing horizontal line test. This time, though, my limits are going to be, because I'm phase shifted for 90 degrees from sine, and so that value is going to be limited from 0 all the way through to pi. And so quadrant 1 and quadrant 2 are where you're going to find the arc cosine functions. And then finally, for the tangent function, we put a similar restriction on here. Again, it's from negative pi over 2 to pi over 2. Okay, so again, quadrant 4 or quadrant 1. Now that solves my horizontal line test problem. And now I have a function that has a true inverse function. So when I'm looking for that angle, then the sine or arc sine function is going to fall in quadrants 1 and 4, but cosine is going to be in quadrant 1 and 2. And then finally, tangent is also in quadrant 1 and 4, same as the sine function. So let's try this then with those restrictions applied. So where is the arc cosine of negative radical 3 over 2? Well, if I had a unit circle, oh, I do have a unit circle. How handy. Uh, so remember that uh, cosine is the x value, right? And so where is the x value on my unit circle equal negative 3 over 2? Well, it occurs here, right, at pi over 5, 5 pi over 6. My x value is negative 3 over 2, and it's also negative 3 over 2 here at 7 pi over 6. But remember my restrictions for cosine, it has to be in quadrant 1 or 2, so I have to use this value here. And so in radians, it's 5 pi over 6, or 150 degrees. If possible, find the exact value of arc tangent of negative 1. Well, that one's pretty easy. I don't even need the unit circle for that. Arc tangent is negative 1 when I have a plus or minus radical 2 over 2 over radical 2 over 2. One of these two values needs to be negative in order for this to equal negative 1. And so tangent only works in the first and fourth quadrants. And so I have to be in quadrant 4, and my value then would be right here, because this is the where it's negative, and so that's at 315 degrees, or 7 pi over 4. Again, or 315 degrees. So in this problem here, I'm going to find the secant of the arc sine of 4 over 7. Now, this is a problem that, as long as I'm not asked to create this into decimal places, I could actually solve this without a calculator. And so we'll solve it without a calculator first, and then with a calculator. Okay, so the first thing I want to do is kind of describe what's going on. So I'm going to create a triangle where I have an angle theta. Must be a right triangle. Okay, that was an error I saw a lot on the last test. So make sure you have a right triangle here. And sine of theta is, that's what arc sine is saying, is that the sine of theta is 4 over 7, right? And so that's opposite 4 over 7 hypotenuse. And I have this adjacent side. Let's just call that A. I don't know what that adjacent side is yet, but we're going to figure that out. In fact, I could use the Pythagorean theorem to solve that, right? So a squared plus b squared equals c squared. So a squared plus my b side, this is my b side here, 4, so 4 squared equals 7 squared. So a squared equals 16, I'm sorry, a squared plus 16 equals 49. Subtract 16 from both sides, and I get a squared equals 33. Now, if I square root both sides of this, a could equal plus or minus radical 33. And this is where knowing that I occur in, remember for cos, or for the, this is the inverse of the sine function. And so for the sine function, I am in quadrant 1 or quadrant 4. Okay, one of those two. Y value is positive. I have to be in quadrant 1. So I have, so this A value then equals the square root of 33. Okay, so that kind of, what is that? That doesn't tell me what the angle theta is, though, does it? But I don't really need to know what theta is, because I'm asked for what is the secant of that. Well, secant, remember, is 1 over cosine, right? So let's kind of break this down. Secant is 1 over cosine. And since cosine is adjacent over hypotenuse, then the secant is hypotenuse over adjacent, right? It's just this thing reversed. So then I have these two sides. I have the hypotenuse is 7, and my adjacent side now, this is theta, opposite, this is adjacent, is radical 33. And if I would rewrite this, if I asked for an exact answer, I would expect to see this as 7 radical 33 over 33. But for the purposes of putting this into the calculator to prove this to you, I'm going to leave it as 7 over radical 33. So the other way to solve this, of course, this is without a calculator, and you may be asked on a SAT or ACT, a non-calculator portion, to solve a problem just like this. Okay, and so you need to know how to do this without a calculator. But let me show you what that looks like with the calculator as well. Okay, so the first thing I want to do is let's find that 7 over radical 33, right? Let's clear that out, and I'm going to go 7 divided by the square root of 33. And I get 1.218. Okay, so that is here. Using the calculator, then this is 1.218. Okay, that is what? That is 7 over radical 33. Okay, that equals that, just to show you where I got that. Now, if I was to plug all of this into a calculator here, the way I would have to do that is I would start off with the arc sine of 4 over 7. So again, clearing my calculator out, I'm going to do shift sine 4 divided by 7. And I get 0.608. Okay, so that's now this x value. So what is the secant of 0.608? By the way, this is radians, not degrees. So the secant value of that, remember, secant is 1 over cosine. So I have to find the cosine and then find the inverse or the of cosine. So cosine of 0.608 equals 0.82, and then the inverse of that, or 1 over that, is 1.218. Hey, look at that, 1.218. So there you go. That shows you that these are the same answer. Okay, so well, unless it says to use the calculator, you need to try to evaluate this to an exact answer without a calculator. So let's try one more of these. So tangent of, or arctangent is negative 12 over 5. Okay, so here's my triangle. This, remember, tangent is opposite over adjacent. So this is my opposite side here is 12, which is my y value, and my x value is 5. Okay, but I don't know which of these is positive and which is negative, at least not right away. But according to my restrictions on here, my tangent occurs in this half, right? In other words, in quadrant 1 and 4. Well, 1, everything is positive, so it can't be in quadrant 1, so it's got to be in quadrant 4. Well, in quadrant 4, my x's are positive and my y's are negative. So this 12 actually is the negative value. Okay, so it looked like this, where I go negative 12 theta, and this side length is 5. Yes, I could have easily put a negative here, but this is a better representation because actually my angle is down this way like that. Okay, so now I have the tangent. I can calculate the hypotenuse for that, right? So 5 squared, so c squared, or my hypotenuse squared, equals 5 squared, it's 25, plus negative 12 squared is positive 144. And so hypotenuse then equals the square root of 169, if I add these two together, which is 13. So here my hypotenuse equals 13. Okay, so now I have the cosecant. Well, cosecant, remember, again, is 1 over sine. And sine equals opposite over hypotenuse, so negative 12 over 13. So then my cosecant is the inverse of this. It equals 13 over 12. And then, of course, it's all negative. And so there's your final value for that. And if I was to put this into a calculator, it would give me a value of 1.083 negative. Okay. And you could put that into a calculator to test it if you'd like. All right, so this last slide here, I'm going to use a calculator to evaluate the expression of arc cosine of 0.28. Now, the arc sines and arc cosines don't care if your degrees or radians. Okay, you could get an answer both ways, and they'll be equivalent to each other. Just depends on what you're set to. So in this case here, I want arc cosine of 0.28. Okay, so we could find that in radians and we could find it in degrees. It doesn't really matter. Let's do the first one in radians since my calculator is already set up there. So again, it's just second cosine of 0.28, and that equals 1.287 radians. Okay, and if I wanted to convert that to degrees, remember I would just take 1.287 and multiply that by 180 over pi, right? And so I should be able to find that pretty easily. So let's look at the arctangent of negative 8.45. This time I'm going to set my calculator to degrees to give me an answer in degrees. And remember that, okay, so this tangent is negative. This arctangent is negative. So my answer should be also negative, right? Because opposite over hypotenuse means I'm in quadrant 4 somewhere. And so this answer is going to be somewhere in the negative range. And so let's go put that into the calculator. I'm set to degrees. Yep, I'm in degrees. So arctangent then of negative 8.45 is negative 83.25 degrees. If I had my calculator set to radians, I would have gotten this answer in radians like I did here. Okay, just make sure that you're answering the question based on what it asks for. And I think that you might find it easier to use degrees rather than radians because this is a little easier to relate to. Okay, thank you.